Hi, kids. All right, so we are now going to explain this because if you take a look, like, look, hey, the water level on this side is here, and the water level on this side is right about there. As you can see, there is definitely water in there. And you might be like, oh, wait a second, Lindenberger. Wait a second. This is all the same fluid, and it is. It's all water because, that's what you want your dog to drink. And then you might be like, well, wait a second, Lindenberger. I memorized, we did this one situation where, I had a big vat of water over here and I had less water on this side. And when we opened the valve, it came up to the same level. And you might be like, And you know what? Yeah, it did go to the same level for that situation, but this is a different situation. And when we're in physics, we don't memorize things, we understand things. And you might be like, all right, well, I still don't really get this. Why does this happen? And luckily, hopefully you'd go, well, how do we solve things in physics class? Oh, right, we draw a picture. So let's draw a picture of what's happening. So on this side, I have a big vat. Here's my giant vat. This is important, it is closed. It is not open to the atmosphere. And then on this side, I have my dog bowl, which is open to the atmosphere. And on this side, the water level is much higher than this level. And you might be like, well, what the heck? That seems weird. Well, let's pick some points and let's try to figure stuff out. Okay? So right now, the water is not moving, so the water has to be in equilibrium, right? Yeah, it does. Which then means the pressure right here and the pressure right here have to be exactly the same. Because if this had a higher pressure than this, well, then the water's going to flow that way. And we saw that at the start that the water did flow that way because at the start, this pressure was higher than this, which is why it flowed that way until it ends up with, in equilibrium. So then let's go, all right, well, if this pressure and this pressure have to be the same, then you have to figure out, well, how do you figure out the pressure? Oh, well, how do you figure out the pressure? At this point, you go, what's above it? Well, what's above that point? Well, there's a bunch of water above it, so we have to account for that. So let's account for that. Rho GH, where I am going to call that H1, and that would be H1. Plus, what else is above it? And some of you are going to be like, oh, well, I just memorized there's always atmosphere. That's not the pressure of the atmosphere because it was closed. And you saw when we were doing it that it was gurgling up and stuff like that, that the pressure up here is actually a lot less than the atmosphere. Okay? Now, it's not going to be a vacuum because, there's still some air in there, but it's way less pressure. So I'm going to just call this plus the pressure from the air in that part. Okay, it's definitely not from the atmosphere, but it's from the air. All right, well, what do we have on this side? Well, on this side, we have a little bit of water. So I'm going to say rho G H2, but on this side, we definitely have the pressure from the atmosphere. And if we wanted to, we could actually solve for the pressure that's in there, where if we measured this height, okay, and we measured this height, okay, we could plug in this height, and we know it's water, so we know the density is 1,000 kilogram per meter cubed, and we know which planet we're on, we know what this is, so then we could actually solve for that and go from there. But again, when we're struggling in physics class, what do? We draw a picture, we use our picture to write our equation, and we make sense out of it. See? And now your dog can drink all day long and be happy. Bye, kids.